Right, it's Dr. Bunsen Honeydew here again. You might be able to hear the humming of the motor in the background. I've got the 8-banger running here in first gear. It has a 2-speed transmission now. It's currently looking at the waveform here of the output of the FET, and it looks pretty stable. Looks kind of interesting, I'd say. Looking at about 64, between 63 and 64 volts peak to peak, and running at about 200 and varying anywhere from about 210 to 225 hertz. And we're sitting on the 20 volt scale, times 10 mode here. So, if we put this onto the next setting, we might get a more accurate peak-to-peak reading. It's looking like about 67.4 volts peak-to-peak, and about 217, 18, 16 hertz. I'll give you a quick look at the rig while it's running before we shift gears here. I'll try and hold it as steady as I can. There's the that's the 8-banger with the new added drive coils, so there's 4 now. Right here, if you can see that, there's the transmission. I have 2 Hall probes, one at one position and angle, and as you can see that second one there that has the blue and red heat shrink there. That one was really difficult to get mounted, and that sweet spot seemed to change over time for some reason. But there's that. Another new addition is a homemade power supply using a Variac, which is a variable AC transformer. One big honkin' anti-ripple cap, 39,000 microfarads. 25 amp bridge rectifier. And the only thing I don't have done yet is I think I need to put a voltage regulator on it, which I just bought today. That goes up to 30 amps, or sorry, 5 amps, 30 volts roughly. You can see the voltage right now is about 10.85-ish. And we'll turn this one around here so you can see that. We've got about 2.3839 amps, so it's drawing a fair amount of current, around 10 volts. What was it? 10.84 times 2.39. Yeah, it's chewing up about 25 watts right now, which is really bleh. So on the circuit board here, we can see I've got a little wire. Oh, washout. Now you can probably still see it with that light. This wire here is my my transmission shifter here, and once I get the camera back on the scope again to watch the increase of the frequency and how the waveform behaves as it's picking up speed, and then I will switch from the FET output to the Hall probe sensor output and take a look at that, which has changed yet again, and it's doing a pretty funky dance, so I think you'll enjoy that. Anyways, we're going to shift gears here. Actually, I'll do it, see if I can do it here. With the camera on, the action. A little bit of washout there. I need some light to do my thing here, so here we go. Okay, can't see it, but I'm sure you can hear that sound. It's getting higher and higher and higher. And let me turn this light off. You can see the current has come down quite considerably. It's about 1.5 and decreasing. The voltage has gone up. So current's coming down, voltage going up, and our RPMs are going up, and you can bet our power consumption is going down. Now here is the, I forgot to do the waveform here. Well, we didn't get to see it speed up. But you can see we've increased the frequency. We're up to, let's stretch that out a bit. It's fluctuating between, geez, it's all over the place, 300 and 400 hertz. The peak-to-peak voltages remained more or less the same, 64, 65. Let's try a larger scale here. 68.4. Well, it went up just a titch. So you can see the waveform is very, very stable. It is smooth and locked. So we get a nice positive going spike with a lot of ringing after that, and then a funky little dip down right to zero, I guess, would be your zero line. Or possibly maybe a negative going line, I don't know. Okay, before we run out of time here, let's take a tachometer reading. Come on. We're reading 2,984 RPMs. Now we're going to turn the camera around here. Back this up just this pad. Alright, now we're going to add some magnet power again. I went and picked up a whole bunch. I just blew $150 on magnets again today. Really didn't plan on spending that much, but I was like a kid in a candy store. Alright, here we go. We got the little 3/4 inch ferrite magnets. Just the little guys, the weakest ones I got. And we got a little bit of speed increase here. Current meter just shut off. Current looks like it's coming down. RPM is going up. Let's try this magnet here on this side. Polarity, and we're going faster. Oh, my magnets are starting to not like that. But we got the current down under an amp, and those RPMs really took off there. I wish I had a tachometer that would stay on. Just push the button and it would stay on. You gotta hold the goddamn button down. Anyways, I'm gonna have to reinvent my rotor here so it doesn't fly apart on me and kill me. But anyways, yeah, let's have a quick look at, if I got some time here, we'll have a quick look at the Hall sensor waveform. What's happened? Let's oh! No! I think I just blew a fuse. Maybe, maybe not. Oh, I got the Hall sensor probe now. Oh, it's a nice square wave. Beauty. That's without power going to it, but as soon as I energize everything, that wave goes funky doodle. I'm going to switch back to the slow speed, and because I have to restart it to get it to go. Come on. Can't see a damn thing. Okay, that should do it. Maybe not. Yeah, that should do it. Okay, let's try it again. No, I blew something up. Alright, we'll just call that one a finito, and next time I'll have my lab assistant Beaker here, and he'll be talking about me. Me.